Space is beautiful. But beauty out there hides something far more haunting. Beyond the glitter of stars and the calm swirl of galaxies lies a universe that is vast, indifferent, and sometimes terrifying. A place where light can be swallowed whole, where worlds drift through endless night, and where the very fabric of reality begins to tear. For all its wonder, the cosmos has a dark side, one that humbles even the brightest minds who dare to look too deeply into it. Imagine standing in the middle of infinite emptiness with no stars, no sound, no horizon, or witnessing a burst of radiation powerful enough to erase a planet before you could even blink. Or imagine falling into a place where time slows, light bends, and every law of physics you've ever known simply stops working. These aren't scenes from science fiction, they are real places scattered across the universe we call home. From vast cosmic voids that stretch for hundreds of millions of light years to invisible forces that tug at entire galaxies. From dying stars that unleash unimaginable energy to the edges of the universe itself, where light can no longer reach us. So let's journey into the places where even light fears to go. This is the most terrifying places in the universe. In the vast map of the universe, there are places filled with light. Clusters of galaxies, stars, and nebulae painting the cosmos with brilliance. And then, there are places where the universe seems to have forgotten to exist. One of those places is called the Boötes Void, a region so enormous, so empty that astronomers simply call it the Great Nothing. It lies about 700 million light years away, in the direction of the constellation Boötes. At first glance, there's nothing unusual about that patch of sky, until you look deeper, because within that region, spanning nearly 330 million light years across, there are almost no galaxies at all. To understand how strange that is, consider this. If the universe were an ocean of galaxies, the Boötes Void would be a hole large enough to swallow tens of thousands of Milky Ways, and still have room to spare. It's not just a gap between clusters, it's an entire region of the cosmos where matter itself is missing. Astronomers discovered it by accident in the 1980s while mapping the distribution of galaxies across the sky. Where they expected to find countless points of light, they found nothing. A hollow so vast that it challenged our understanding of how the universe is structured. The universe, as we know, is woven together in a cosmic web. Long filaments of galaxies stretching across space, separated by dark voids. But even among these voids, the Boötes Void stands out. It's more than twice as empty as typical cosmic gaps. In its center, you could travel hundreds of millions of light years in any direction and never encounter another galaxy. Imagine being inside it. There would be no stars, no galaxies, no Milky Way shining faintly in the distance. Only darkness. The nearest light might take hundreds of millions of years to reach you. Even the cosmic microwave background, the faint glow left from the Big Bang, would look dimmer there. Some scientists believe this vast emptiness formed naturally as the universe expanded, a byproduct of how gravity and dark energy shaped space over billions of years. Others suggest something stranger. That the Boötes Void might not be a single empty region at all, but the overlapping result of multiple smaller voids merging together. An emptiness born from other emptinesses, creating a cosmic desert beyond comprehension. And yet, some theories go even further. A few physicists once speculated that regions like the Boötes Void could be the scars of cosmic collisions, remnants of where another universe might have brushed against ours long ago. While there's no evidence for that yet, the idea adds an eerie weight to what we see, that this might be a mark left behind by something far beyond our own reality. What makes the Boötes Void so haunting isn't just its size, it's what it represents. A reminder that most of the universe is not stars or galaxies, it's emptiness. For every cluster of light, there are vast oceans of darkness in between. If you could stand at the center of the Boötes Void and look around, you wouldn't see a single star. You would see only blackness in all directions. And perhaps if you waited long enough, you might see a distant galaxy flicker faintly, a single spark in an eternal night. In that silence, surrounded by nothing, the universe would feel truly infinite. The Boötes Void isn't just a hole in the universe, it's a window into what most of the cosmos really is. Not stars, not galaxies, not life, but nothing at all. If the Boötes Void is a hole in the universe, then the Eridanus Supervoid is something even stranger. A wound, it's not just a region of emptiness, but a cold mark on the very fabric of the cosmic microwave background, the afterglow of the Big Bang itself. A place where the universe's earliest light runs cold. Astronomers first noticed it in the early 2000s while studying the sky using data from the WMAP and later Planck satellites. When they mapped the temperature of the universe's background radiation, the faint uniform glow left over from its birth, they found something deeply unsettling. Amidst the near-perfect smoothness of space, one spot stood out, a cold spot, hundreds of millions of light-years across, colder than anywhere else in the observable universe. That coldness meant that somehow there was less energy coming from that part of the sky. Something was sapping the cosmic light as it passed through, and when astronomers looked deeper, they found that the cold spot aligned with a vast region nearly 1 billion light-years wide, a place with far fewer galaxies than anywhere around it. They called it the Eridanus Supervoid. To understand why this is so bizarre, we have to remember that the universe's structure, the cosmic web, is a delicate balance. Galaxies cluster along invisible threads of dark matter, while between them lie the voids, the empty spaces. But the Eridanus Supervoid isn't just another empty bubble, it's too big, so large in fact, that our standard models of the universe struggle to explain how such a vast underdensity could even exist. If you could drift inside it, you'd be entering a realm where galaxies thin out until there are almost none. Starlight would fade. Cosmic radiation would drop. The sky would grow quieter, not because sound doesn't travel in space, but because there would be nothing left to make noise. And it's cold, not in the sense of temperature you could feel, but cosmically cold. Photons from the Big Bang lose energy as they climb out of this gravitational emptiness. The deeper the void, the colder the light becomes. It's as if the universe itself shivers when it passes through. But what truly unsettles scientists isn't just the emptiness, it's the possibility that it might not be natural. Some have suggested that the cold spot could be the bruise of another universe, an imprint left when our cosmos collided with a neighbouring one during its earliest moments. If that were true, the Eridanus Supervoid could be evidence that our universe isn't alone, that beyond our cosmic horizon, there are others pressing against ours like bubbles in a multiversal sea. Of course, not everyone agrees. Many researchers believe the cold spot is simply a statistical fluke, a coincidence in the random distribution of cosmic background radiation. But the numbers don't quite add up. It's too large, too deep, and too distinct to dismiss easily. So we're left with uncertainty, a void that refuses to give us answers. Either way, it stands as one of the strangest and most haunting features in the universe, a vast, cold scar on the sky marking the place where the universe itself might remember its first collision. All across the universe, galaxies are moving. Some drift apart as space itself expands, while others swirl around clusters bound by gravity. But when astronomers mapped the motion of nearby galaxies, they noticed something deeply unsettling. A mysterious gravitational pull drawing everything toward one hidden region of space. Our own Milky Way is part of that motion. Along with billions of other stars, planets and galaxies, we are falling, not through space, but with space, toward a place we cannot see. A place known as the Great Attractor, located roughly 200 million light-years away in the direction of the constellations Norma and Centaurus. The Great Attractor is one of the strangest features ever discovered in our cosmic neighbourhood. It's not an object, not a single black hole or galaxy cluster, it's a region, a concentration of mass so immense that its gravity is pulling entire clusters toward it, distorting the flow of galaxies across hundreds of millions of light-years. Even our local group containing the Milky Way and Andromeda is racing toward it at over 600 kilometers per second. That's more than 2 million kilometers per hour. Yet, despite this enormous motion, we still have no clear idea what's actually there. The reason is simple. The Great Attractor lies hidden behind the thick disk of our own galaxy. This area of the sky is called the Zone of Avoidance, a region veiled by gas, dust, and starlight that blocks our view in visible wavelengths. It's as though the universe placed a curtain between us and the thing pulling us in. Through X-ray and radio telescopes, scientists have begun to peer behind that curtain. They've found the Norma Cluster, a massive collection of galaxies rich in dark matter and blazing with hot gas. But the pull we feel is too great to come from this cluster alone. The gravity extends far beyond it, suggesting that the Great Attractor might just be a small part of something even larger. The Laniakea supercluster, the enormous structure that houses our own Milky Way and thousands of other galaxies. In this vast cosmic landscape, galaxies are not stationary islands. They move in gentle, coordinated flows, like leaves caught in an invisible current, all drifting toward one point of unimaginable density. It's a haunting thought. We are all passengers on a cosmic river, heading toward an unseen destination. A journey not of our choosing, toward a place we cannot observe and may never reach. And beyond the Great Attractor lies something more colossal still. The Shapley supercluster, another gravitational giant that may continue the pull even farther into the darkness. If the Great Attractor is the first hand tugging us through the void, the Shapley concentration is the second, drawing everything deeper into an unknown cosmic abyss. What makes the Great Attractor terrifying isn't just its size or mystery. It's the realization that our galaxy, our stars, and even the space between them are being carried along by a force we cannot resist or understand. We are being pulled, not toward danger, not toward safety, but simply toward the inevitable. And one day, billions of years from now, this silent motion will continue. The Milky Way and its neighbors will merge, drawn onward into the flow of Laniakea, while the rest of the universe expands away, fading into darkness. The Great Attractor will remain hidden, unreachable, its gravity silently shaping the paths of galaxies that will never know its name. It is the invisible pull of destiny, the quiet hand of gravity, guiding us into the unknown. Among the most extreme objects in the universe are those born from death, the corpses of once mighty stars. But while most stellar remnants fade quietly into darkness, some return with a vengeance. These are the Magnetars, the most magnetic objects known to exist, and perhaps the most terrifying stars in the cosmos. When a massive star reaches the end of its life, its core collapses under its own gravity, and its outer layers explode in a supernova. If the star isn't quite heavy enough to form a black hole, it becomes a neutron star, a city-sized sphere of ultra-dense matter spinning rapidly in the void. But in rare cases, perhaps only 1 in 10 neutron stars, something far more violent happens. The collapsing core twists magnetic fields into knots so intense that they warp the very structure of space around them. This is how a magnetar is born. A single magnetar just 20 kilometers wide can possess a magnetic field 1,000 trillion times stronger than Earth's. On the surface of a magnetar, gravity crushes everything to unimaginable density. A single teaspoon of its material would weigh as much as Mount Everest. And yet, it's not gravity that makes them so fearsome, it's the magnetism. These fields are unstable, coiled with immense tension. When they snap or twist, the energy released can rival that of a supernova, but concentrated in a fraction of a second. These outbursts are called starquakes. And when they happen, magnetars unleash gamma-ray flares so powerful they can outshine every other X-ray source in the Milky Way combined. In 2004, one such magnetar, SGR 1806-20, about 50,000 light-years away, erupted with a flash of energy that briefly altered Earth's upper atmosphere. Had it been just a few light years closer, that single flare could have stripped away our ozone layer and sterilized the planet. It was a reminder that even across the vastness of space, magnetars demand respect. Despite their fury, magnetars don't last long. Over tens of thousands of years, a blink in cosmic time, their magnetic fields decay, and they settle into quieter forms of neutron stars. But during that brief window, they are the universe's most violent survivors, small, dead, and yet somehow more alive with power than any living star could ever be. They are proof that the universe doesn't need size to be terrifying. Sometimes, horror comes in the smallest, densest forms imaginable. At the heart of nearly every galaxy lies a supermassive black hole, a gravitational monster millions or even billions of times more massive than the Sun. Most sit quietly, feeding only on the occasional star or drifting cloud of gas. But some are hungry, devouring matter at such a furious rate that they transform into the most powerful and terrifying beacons in the universe. These are quasars, the blinding hearts of galaxies. When gas, dust, and even entire stars fall toward a supermassive black hole, they don't vanish instantly. Instead, they spiral inward, forming an accretion disk, a swirling maelstrom of plasma heated to millions of degrees. Friction, gravity, and magnetic forces twist together, unleashing torrents of radiation so intense that the disk itself can outshine its entire host galaxy. A single quasar can emit 1,000 times more energy than the Milky Way, all from a region smaller than our solar system. To an observer billions of light years away, it would appear as a blinding point of light, brighter than everything else around it, yet powered by darkness. This is the paradox of a quasar, a light born from destruction. As material falls closer to the event horizon, it heats to unimaginable temperatures and emits radiation across the spectrum, from visible light to X-rays and even gamma rays. Jets of charged particles shoot out from the black hole's poles at nearly the speed of light, piercing intergalactic space for millions of light years. If one of those jets were aimed directly at Earth, it could vaporize our planet's atmosphere in seconds. The largest known quasars are almost beyond comprehension. Some are so luminous they could be seen from across the entire observable universe, ancient beacons from a time when the cosmos was young. The quasar Ton 618, for instance, harbours a black hole more than 66 billion times the mass of the Sun. A monster so powerful that its energy output dwarfs every star in our galaxy combined. In their youth, quasars were far more common. Billions of years ago, galaxies were colliding and merging, feeding their central black holes with rivers of gas. This era, sometimes called the Cosmic Dawn, was lit by quasars blazing in every direction, their light piercing the early fog of the universe. But like all things, even quasars fade. As their fuel runs out, their radiance dims and the black hole returns to silence. A sleeping giant at the core of a quiet galaxy, waiting for its next meal. Today, when we look at distant quasars, we're seeing the ghosts of a younger universe, light that has travelled billions of years to reach us. Each one a cosmic lighthouse, shining from a time when the universe was only a fraction of its current age. They remind us that the cosmos is not peaceful. It's a place where gravity and energy wage endless war, where even light itself can be born from the edge of oblivion. There are places in the universe where time itself begins to break down, where the rules that govern everything we know simply stop working. These are the realms of black holes, and at their edge lies one of the most terrifying boundaries in existence, the event horizon, the point of no return. A black hole begins as the corpse of a massive star, crushed under its own gravity after a supernova. As the core collapses, it becomes so dense that not even light, the fastest thing in the universe, can escape its pull. The event horizon marks the invisible line that separates the possible from the impossible. Cross it, and every path forward leads only one way, deeper into the abyss. To an outside observer, the event horizon looks calm. Matter falling toward it seems to slow down, fading and stretching as time itself dilates. But this is an illusion created by gravity's extreme power. For the falling matter, for anything crossing that boundary, time continues normally. It simply never returns. Imagine hovering near one. From your perspective, the rest of the universe would appear to accelerate wildly. Stars aging, galaxies colliding, eons passing in moments. While you drift at the edge of eternity, That's because black holes don't just warp space, they warp time itself. And yet, what lies beyond the event horizon remains one of the greatest mysteries in physics. At the center, theory predicts a singularity, a point of infinite density where all known laws of nature collapse. Here, the equations of relativity break down, and even quantum physics offers no clear answers. It's as though the universe itself refuses to reveal what happens next. If you were to fall through, your fate would depend on the size of the black hole. In smaller ones, tidal forces would tear you apart long before you reach the center. An effect scientists call spaghettification, where gravity stretches you thinner and thinner until you're reduced to atoms. But in the case of a supermassive black hole, the journey might feel strangely gentle. You could cross the event horizon without feeling a thing, unaware that every direction now leads only inward. To distant observers though, you'd never quite vanish. Your image would freeze just above the event horizon, dimming and reddening as your light is stretched by gravity. You'd become a ghost, suspended forever on the edge. A memory written in light that never escapes. What makes the event horizon truly terrifying isn't just its destructive power, but what it represents. A place where the universe hides its deepest secrets. It's the ultimate barrier, not just to matter, but to knowledge itself. For decades, scientists have tried to see beyond it. In 2019, the Event Horizon Telescope gave us our first glimpse. A glowing ring of light around a dark void. The silhouette of a black hole in the galaxy M87 55 million light-years away. It wasn't the black hole itself we saw, but the fiery chaos of matter spiraling toward oblivion. Standing at the edge of an event horizon is to stare into the unknown, into a place where space folds, time halts, and everything that enters becomes part of a cosmic secret we may never uncover. It is not just a boundary in space, it's a boundary in understanding. A reminder that even with all our science and curiosity, there are still places the universe does not allow us to see. The event horizon is the universe's final frontier, the edge where reality unravels and the unknown begins. For as long as humanity has looked up at the night sky, we've wondered, how far does it all go? How far does the universe stretch before there's nothing left to see? The truth is, there is an edge, not of the universe itself, but of what we can ever know. It's called the edge of the observable universe, and it marks the ultimate limit of reality as we can perceive it. The observable universe spans about 93 billion light-years across. That number is staggering, not because of what's within it, but because of what lies beyond. Everything we can see, every galaxy, every flicker of light exists inside this vast cosmic bubble. Beyond it, there may be more, perhaps infinitely more, but no signal, no photon, no whisper of information from those regions will ever reach us. And that's because the universe isn't static, it's expanding. Not like an explosion spreading through space, but as space itself stretching, carrying galaxies away from each other faster and faster over time. The farther something is from us, the faster it recedes, until eventually it moves away faster than light can travel through the expanding fabric of space-time. When that happens, it slips beyond our cosmic horizon, forever invisible, unreachable, and effectively gone. Imagine watching the universe dissolve in slow motion. One by one, the most distant galaxies fade from view, their light stretched into darkness by the relentless expansion of space. What we're left with is an ever-shrinking island of visibility. A cosmic prison, not of walls, but of physics itself. The light we see from the edge today isn't from galaxies as they are now. It's ancient, 13.8 billion years old. The faint afterglow of the Big Bang, known as the cosmic microwave background. When we observe that light, we're not seeing stars or planets, but the universe itself as a newborn. A glowing fog of particles long before the first galaxies formed. That boundary, that faint radiation still whispering across the sky, is the edge of what we can ever observe. Beyond it lies a realm that no telescope, no probe, no human mind can ever reach. It's not just distance that separates us, it's time itself. The space beyond that limit is expanding away faster than information can cross it. sealing it forever outside our universe's horizon. And yet, we know it must exist. Galaxies, clusters, perhaps even other universes, all continuing beyond what we can see. Reality doesn't end at the edge of the observable universe, only our ability to witness it does. In a sense, looking to that edge is like looking into a cosmic mirror. We're seeing not just how far we can go, but how small we really are. The horizon reminds us that even with all our technology, our understanding, and our ambition, there are boundaries we cannot break. It's the universe's way of telling us, this is as far as light has carried you, and beyond that lies the unknown. And what could be more terrifying, or more beautiful than that? A universe that stretches beyond imagination, a horizon that recedes faster than we can chase it, and an endless expanse of existence we will never touch. The edge of the observable universe isn't a wall. It's a curtain drawn across the greatest mystery of all, what lies beyond our cosmic sight.